The video will prompt you at every segment what you need to do. You are going to interpret into ASL for the first section. And then that's why we'll turn the camera so that when you're doing this, we can see what's on the screen. So
Okay,
that
gotcha.
it's just for that.
Rebecca, I'm just gonna leave the outline if
Yeah.
Trevor just wants to glance.
Yeah,
The first
it's
one's
not
a warm-up.
necessarily in order.
Oh, okay.
Like the warm-ups
almost
are
in
not
The
in-
warm-ups
okay,
weren't, but the
yeah.
rest seem to be in order. There's a
Okay.
warm-up here and then there's a warm-up somewhere.
Okay, is one a voicing and one a signing, or are they both like?
They are both signers, so it gives you an idea of someone,
Okay.
what your audience might look like.
Okay.
Kind of helps to not be signing to a screen.
So this is my audience, the screen.
This is your
So I
audience,
guess, like,
yeah.
pretend that- okay.
And let's
All
make
right.
sure the red light's going and my timer there. And then,
Thank you for doing this, Becky.
oh, you're welcome.
And the volume, did we test it a
We
little
did
bit?
test it.
And we got rid of that volume
Yeah.
thing out of the.
There you go.
Thank you.
See you in a bit.
Tell herself. She helped the slaves. Her name go into the underground. Name Harriet Tubman. Name Tubman. Okay, Harriet Tubman. She was a good woman. The slaves, they wanted to be free, so she helped free them. And she wanted, how did she help? She explained when she was growing up, Harriet Tubman. No, that was the future. We'll talk about the past. Harriet Tubman. Herself. She had a really boring life. She would get whipped when she was a slave, and they would slap her and they would beat her. So until her pick up to forward she was sewing, they would slap her if she was sewing. So when she was growing up, other slaves, they had rocks, and they would throw the rocks, and other people would stone them. They would stone those slaves. They would throw the rocks at them and hit them in the head. They could kill them, and then they would have a scar, and then they would bleed. She had a scar on top of her forehead, across her forehead. For the scar, they had to sew it, give her stitches. And her son's name, whatever his name is. Her son, himself, mom, they were slaves. They started, and they wanted to escape. They wanted to keep it secret. They needed to keep it secret because they were slaves and they were workers, and they weren't allowed to do that. So how did they escape? Her husband was sleeping. They were worried. They opened and entered, and they were all covered up. They had their hoods up. They couldn't see, and they So people were looking all over for them. They were searching. People were everywhere. people just kept searching and searching for them, for Harriet Tubman, and couldn't find her. She was in a tree and she would keep going from tree to tree. And Mom and Dad come back and they had to hide. They were going to come take the dad and the children and the family. And she wanted to take them all and wanted to leave and wanted to be free. That's why her husband came. And they talked about it, that we needed to get, please, we want to get out of here. He said, no, you have to stay. I don't want my young to live here and grow up like this. Her husband said he didn't want to leave Pennsylvania. He didn't want to leave, wanted to stay. So she cried and she left. They didn't have slaves there. There wasn't any there, so they were free.
In essence, gears change the speed and direction of the movement within a gear system. In this case, we're taking the turning motion and power from this part of our machine and we're transferring it to the rear tire, another part of our machine. Now, this is a good example with a bicycle in your classroom to introduce gears. It's kind of exciting to see a bicycle upside down in one's classroom here. And have your students walk around the bike and take a look at the gear system and ask them what happens when you turn the pedals. What other parts of the bicycle are in motion? They can draw this and note this, record this within their journal. You want to ask them, where are the gears on the bike? And what do they look like? You can brainstorm what it is that gears do and how they work. Have your students walk around and note how many gears there are and ask them why the gears are different sizes. What's that going to do within the gear system? And in this case, when riding a bike. So now the next activity with them is to take a piece of chalk and put a mark on your rear tire. In this case, I have it right here. And set it at a reference point. I'm going to use the frame. I'm going to do the same with our pedals. Now I'm going to set the bike on its lowest gear ratio. And I'm going to have a volunteer come and turn the pedals. And the rest of the class can count how many times the rear tire goes around while watching that chalk mark. You'll notice at the lowest level on this bike, it's a 1-to-1 ratio. So 1 turn for the pedals equals 1 turn of the rear tire. Why is that? What gears are being turned here? What are the size of those gears? Now, you also want to try this for the highest gear on the bike, and then you'll see what gears the highest ratio sits on. You want to make note of that and count how many times the rear tire moves around. It'll probably be about 3 or 4 times. So what gear would you want to be in if you were climbing a really steep hill with your bicycle? Or what gear would you want to be in if you wanted to go really quickly based on the information that we know? What you're likely to notice with your students is that in the lowest gear selection, the bike is going to pick the small gear up the front and the large gear at the back. And they're roughly the same size. We see that when we turn the front pedal, the rear tire turns at the same rate. And that's because they're the same size. We have a 1-to-1 relationship. Now in the highest gear, it's going to select the largest gear at the front and the smallest gear at the back. And we see the difference in size of those gears lends to the tire at the back turning quite a few more times than the pedals here at the front. So have your students count how many teeth are in the small gear at the back and the large gear at the front and see if there's a similar relationship between the amount of spins in the rear tire versus the pedals. Now, we have little mechanical advantage here when we're in a high gear, but we have a higher rate of speed. Similarly, low speed in a lower gear, but a greater mechanical advantage. We've just taken a look at a bicycle and how gears help it in its functioning, and now it's time to really get hands-on with gears so that we understand how they really work. So ask your students what objects in their surroundings function with the help of gears other than a bicycle. They might come up with items that they're familiar with, such as a watch, can opener, maybe a guitar, a wrench. These are all great items that you want to keep track of as the unit progresses. Now, if you have access to a commercially created gear system, they're really easy to put together and to take apart, and they're not time-consuming to work with, which is really a plus in the classroom. Now, if you don't have access to that, you can find individual gears at a dollar store or at a similar outlet that you can pin to some cardboard and create some really creative systems in this format. Now, if that's also not an option, you can create some gears at a poster board and some pins and cardboard as well. I'd advise you to print out some templates, glue them directly on the poster board, cut them out, and raise the teeth up so that they mesh appropriately when you put them together. And once you have a system such as this here set up, have your students explore that in sort of an unstructured way, and then you can ask those key questions about the relationship in size, the amount of teeth. You might want to mark one tooth on each gear so that they can see how many times they go around and the relationship between them. The idea is essentially that gears transfer force from one place to another. These are questions that you want to focus in on those ideas, that they change the direction of a force, they also change the speed of a force, and they increase that turning force. So you want to introduce the idea of torque and clockwise versus counterclockwise motion, and similar ideas such as this. Now, if you have a commercially set up gear system, they often come up with different plans, so you can challenge your students as a culminating activity to put other things together to construct, maybe with use of an axle, a watch system to turn an hour hand and a minute hand. They're quite fun and creative. So have fun with gears. Hopefully the activities and demonstrations contained within this video will help you to communicate that both pulley and gear systems transfer motion from one place to another, transform one kind of motion into another, change the direction and speed of an object's motion, as well as change the amount of force required to move an object. Now, these devices are generally used to make our everyday lives easier, and when combined with the spirit of inquiry, can be kind of fun to explore with your students as well.
Hello everyone, and welcome to our video lesson on integers and bedmass. To get started, we are going to talk a little bit about some of the numbers that you already know about from your previous math classes. And we'll start with the natural numbers. The natural numbers are the numbers starting with number 1 and going up by ones as far as you can count. So I've listed a few examples, like the number 1, 2, 3, and 4. These are all natural numbers. And this pattern that I've established continues. Those 3 dots mean and so on. You'll notice I've put these numbers in this pattern, the natural number pattern, in a set of brackets. These brackets are called set brackets. So the natural numbers are the numbers 1, 2, 3, 4, and so on. They have a special symbol, and that symbol is this fancy letter N. And that's the symbol we use in mathematics for the natural numbers. There are other types of numbers that you've learned about. You'll notice the number 0 is missing from my set of natural numbers. When we include 0, we say we're working with the whole numbers. The whole numbers is just the set of natural numbers including 0. And if we were to use a symbol to represent the natural numbers including 0, we would use a fancy letter N with little 0 at the bottom. And then finally, you've worked with the integers in the past. Integers are positive and negative whole numbers. So the numbers -3 up to 3 and so on in both directions. Just to restate, these are positive and negative whole numbers. So the integers are positive and negative whole numbers. We can think of the integers as being represented on a number line with 0 in the middle, the negative integers to the left of 0, and the positive integers to the right of 0. And we could say that numbers like 4 and -4 are opposites of each other. So if we think of integers on the number line, if we're adding integers, adding means we're taking a number and moving to the right. So adding moves to the right. And we're to subtract. Subtraction is the opposite. Subtraction moves on the number line to the left. Let's try some examples. If I wanted to determine what -3 take away 1 equals, I could think of -3 on my number line. Find it on my number line. And we said that subtraction means we're moving to the left. So -3 take away 1 means I'm moving to the left 1 spot. So -3 take away 1 equals -4. So if I try another question, like -2 plus 5, well, I find -2 on my number line. And then now that I'm adding, I'm moving to the right 5 spots. 1, 2, 3, 4, 5. -2 plus 5 is equal to